So let's apply some of this knowledge of the inverse into context. Let us consider the equation x plus 5 is equal to 17. What I'm going to do is I'm going to start with the variable x here. And I'm going to build, then solve. So when I move this way, this is x. And to get x plus, I'm adding 5 here. So sorry. What I'm going to do is, to get x plus 5, I need to add 5. Now, what do I do here? On one side, x plus 5 is equal to 17. Now, to solve it, I need to do the inverse of what I did to build the equation x plus 5, or the expression x plus 5. So I need to subtract 5. So 17 subtract 5 is 12. So one way to build my equation is to start with x, and then I need to add 5 to get x plus 5. And then I work on the other side of the expression. I need to subtract 5 in order to get to my solution. So an equation is an open-ended sentence. Let's verify the solution. Our solution right now is 12. Does 12 plus 5 equal to 17? Good question. 17 is equal to 17. Check. It works out. Now, I'm going to work through this algebraically. If I have x plus 5 is equal to 17, what I would like to do is I would like to isolate x. It's called isolating x, and it's really get x by itself. Well, how do I get x by itself? I need to undo this adding 5. So what I'm going to do is I have x plus 5 on both sides, or x plus 5, and I have 17 on the other side of the equation. An equation is like a balance. So what I'm going to do to get rid of that addition of 5 is I'm going to subtract 5. The inverse of adding 5 is subtracting. But if I do that to an equation, I need to do it to both sides of the equation to keep it balanced. Now what's remaining is x. X plus 5 minus 5, that's going to be 0. So that cancels each other out. I'm just left with x. Now I have 17 minus 5 is 12. So let's maybe go to the next one. Consider the equation. 3x is equal to 10.5. Now 3x, I just want to make sure that we understand, this means 3 multiplied to x. So I start off with x. How do I build 3x? Well, I do need to multiply by 3. And I'm going to I'm going to do the inverse. So the inverse of multiplying by 3 is dividing by 3. And what we see is 10.5 divided by 3 is 3.5. Now allow me to do this. 3x is equal to 10.5. I'm recognizing that I would like to get x by itself. But what's happening to x? It's being multiplied by 3. So what I need to do is I need to do the inverse operation of whatever's the 3 represents. Well, 3 represents being multiplied by 3, so the inverse operation is to divide both sides by 3. So 3x divided by 3 will just leave me with x, because I have a common factor of x in the top, x in the bottom. Now 10.5 divided by 3 is going to be 3.5. That's how we do it. So again, I always think that equations and solving equations requires imagination. We'd like to get x by itself, but what's going on is 5 is being added. So I need to subtract 5 to both sides of the equation. Or how can I get rid of that 5? Well, it's the inverse operation of adding 5. So I subtract 5 to both sides. Same thing over here. You would like to get rid of this 3. How can you get, well, you can't, really. It's very difficult because it's 3 times x. Well, how do I get rid of the 3? Well, it's 3 times x. What is the inverse of multiplying by 3? Well, it's dividing by 3. So you're just going to divide both sides by 3. So let's consider the equation q over 4 is equal to 16. Now we have to be very careful here because sometimes our biases and our initial perceptions will not help us out. So I'm going to consider the equation q over 4 is equal to 16. Now if you notice, I'm going to try to build that algebraic expression q over 4. If I start off with the variable q, and to get q over 4, I need to divide by 4. Now, on the other side of the equation, I have 16. To move it backwards, I'm going to multiply this by 4. It's the inverse of dividing by 4. So the answer is 64. 16 times 4, 64. So I'm going to verify the solution. So q is equal to 64. What I have is 64 divided by 4 is equal to 16. 16 divided by 4 is 16, so 16 is equal to 16. I have the solution. I have the value of the variable that makes my statement true. Now over here in algebraic, so what would I like to do? I would like to isolate the variable q. Unfortunately, q is being divided by 4. And the only way to get rid of that 4 is I'm going to multiply both sides of the equation by the inverse of dividing by 4. And that is multiplying by 4. So on the left-hand side, I have a factor of 4 that cancels out, and I'm left with q. q is equal to 16 times 4, or q is equal to 64.